Let's take a look at simplification of radicals in lesson 20. and we have, say we have a radical 50. It's read square root of 50 or radical 50. If you type that in your calculator, you would get roughly 7.07. That would be the decimal. But today we're going to talk about simplifying the radical. So if we were simplifying radical 50, and I'll break down how to simplify in this example, but if we were simplifying, it could be written two different ways. You could have radical 2 times 5 times 5 all encompassed in one sign, or you can have radical 2 times radical 5 times radical 5. These are both the same thing. We are going to generally write with that one though. That is going to be how we're often going to write the radicals in our equations. So let's look at example 20.1. We're trying to subtract 3 radical 50, we're trying to subtract 5 radical 200 from 3 radical 50. What we have to do first is look at what is inside the radical. So we look at radical 50. Now, how we simplify radical 50 is we look at its family tree, so to speak. So what the family tree means is, what are factors of 50? What two numbers could you multiply to be 50? Well, there's different ones outside of using 50 times 1. There's different ones you can use. You could use 25 and 2, because 25 times 2 equals 50. We keep doing our factors until we get to prime numbers. But number 2 is a prime number. Prime number, remember, is where it can only be multiplied by itself and number 1. So therefore we have one prime number here. 25 has factors though, so we can go further. Factors of 25 are 5 and 5. Those are both prime numbers. Now if you notice, if I was to multiply all my prime numbers that are in the family tree of 50, 5 times 5 is 25, times 2, 50. So these are kind of the basics of the radical. Now, all of these are still under the radical in a sense, because it is radical 50. So therefore, when we write this, we can say 3 times radical 2. So we used that one, times radical 5. I used that one, times radical 5. So we get to this point. Once you're here, and you'll be able to speed this up once you get good at it, but once you're here, if you have two of the same number under the radical, let's look at radical 5 times radical 5 for a second. If you have two numbers under the same radical, well, what that is actually going to be equal to is 1 whole number 5. Here's why. If I was to multiply radical 5 times radical 5, that would be radical 25. Well, square root of 25 is 5. So we have this right here. Radical 5 times radical 5 is just 5. So now we're here. This is minus 5 radical 200. Well, the 5 can be multiplied with the 3. They're both whole numbers, so therefore they can be multiplied. So I can say 5 times 3 is 15. I'll do this. 5 times 3 is 15, and we bring down the radical 2, almost like a variable, like you had x. 15 radical 2 is where we're at with 3 radical 50. So that is it simplified. Now we need to simplify negative 5 radical 200 to see if we can actually subtract it. So we're at this point. This is where we're at right now. Now let's look at the radical 200. Look at it over here. What are factors of 200? Well, you got 102. There's a prime number. You have 10 and 10. And then for both 10s, you have 5 and 2. And that gets us down to all these prime numbers. Once again, if you multiply the prime numbers, they would equal 200. So rather than writing it all out, what I always do is I see two 2's right here. So I cross those out because I know that radical 2 times radical 2, that would be radical 4, and that would equal 2. So I take these two 2's out, and I write, here, we got 15 radical 2 minus 5 times 2. So we took those out. We got two 5's here. Two 5's. So I mark those out, pull a little bit closer so you can see. And I know that those equal 1 5. Radical 5 times radical 5 would just be 5. Write that over here, and I'll move to where you can see more of that in a second. And then we're left with just this last 2. It's by itself. It doesn't have a partner. It doesn't have another 2. So therefore, we just keep that as radical 2. So that's where we're at in the problem right now. 15 radical 2 minus 5 times 2 times 5 radical 2. Well, order of operations, do multiplication first. 5 times 2 is 10, times 5 is 50, and it's all negative. So negative 50 radical 2. Is that simplified? So now we have 15 radical 2 minus 50 radical 2. Because they have the same radical, we can consider these like terms, therefore subtracting the 15 from the 50 from the 15. So 15 minus 50 would equal negative 35 radical 2. And that would be your answer. It's the same thing as saying 15x minus 50x. That'd be 35, negative 35x. That's the same concept. We just have a radical in this scenario. So that's how you do simplification of radicals. Let's look at a couple more problems just to make sure we got a good grasp of it. Go this way. Okay. We got 3 radical 2 times 4 radical 12 times 2 radical 3. What I would do in this scenario is I would first simplify the radicals. I would see if we can simplify the radicals. So I look at radical 2. That's already simplified. Can't go any further than that. Radical 12, can that be simplified? It's not a prime number, so factors of 12 are 4 and 3, 2 and 2. So the simplified form of 12, radical 12, would be 2 radical 3. 2 radical 3. Remember, if you have 2 of the same, they come out to be 1 when we're talking about radicals. So if this is now times 4, 2 radical 3. Wrote that kind of small. But go ahead and simplify. 4 times 2 is 8. So let me rewrite all this. 3 radical 2 times 8 radical 3 times 2 radical 3. And radical 3 can't go any further than that. That is simplified already. So now we can multiply. And when we multiply, what I would do is multiply the whole numbers. 3, 8, and 2. 3 times 8, 24, times 2, 48. And then you're actually left with 1 second, make sure that's right. 3 times 8, 24 times 2. Okay. Then you're left with radical 2. Yeah, this is right. Radical 2. Radical 3. Bringing that down. Radical 3. Just like we said before, if we have two of the same, we got two radical 3s, we know that that just equals a positive 3. Because radical 3 times radical 3, radical 9, square root of 9 is 3. 3 times 48 would be 144. Then you have your radical, and we leave it that way. We don't put that in our calculator. We want it simplified. So therefore, 144 radical 2 would be our answer. Let's look at one more example for radicals. Example 20.3 is 4 radical 3 times 2 radical 3 minus radical 6 inside parentheses. So hopefully you guessed it. Yes, you're going to distribute. We're going to distribute and multiply the 4 radical 3 by both. So 4 radical 3 times 2 radical 3, multiply the whole numbers, 4 times 2, 8. Multiply your radicals. Radical 3 times radical 3, we know that that is just a 3. So therefore 8 times 3, 24. 24. So we did the top, that was just the first one. Then we multiply 4 radical 3 times the negative radical 6. This one has no whole number, so therefore it's minus 4 radical 3 radical 6. Now, if we multiply these, this is not simplified. It would actually, your lowest number would be, lowest number is the wrong way to say it. Well, your lowest simplified radical would be the number. This has two radicals. We want everything under one sign. So radical 3 times radical 6 is radical 18, because 3 times 6 is 18. Once we're at this point, square root of 18. Can that be broken down any further? Let's see, 6 and 3, 3 and 2. So yes, it could be broken down because you have 2 3's, and this would equal 3 radical 2. Radical 18 would be the same as 3 radical 2. So then we have 24 minus 4 times 3 radical 2. Negative 4 times 3 is 12, negative 12. So your answer is 24 minus 12 radical 2. And those are a few different problems from simplifying radicals. Let's move to concept B. Page 99. Line parallel to a given line. Parallel lines, if we're talking about y equals mx plus b, we're talking about equation of a line. We know that lines are parallel, or two lines are parallel if they have the same slope, aka the same m, but different y-intercepts. These have to be different, otherwise they have the same slope and same intercept, they'd just be the same line. So for example, if you have y equals 1/2 x minus 4, if I graph that, I'd go down 4 and do my slope of up 1 over 2, up 1 over 2, and there would be this line. So I just did that line. Now if I had y equals 1/2 x plus 2, I graph that at 2, up 1 over 2, down 1 to the left 2, Okay? Try to draw a little more through the line there. You see, now it's my drawing, but these would be parallel lines. Why? Because your slope in both of them is 1/2. Since both of them have the same slope of 1/2, therefore these lines are parallel. Let's look at this one. This one has a y equals negative 1/2 x minus 1. So we have a negative 1/2 x. So I go to my y-intercept. Notice y-intercept doesn't matter. That's just its starting point. But negative 1/2 would be down 1 to the right 2, up 1 to the left 2. That line would look like that. That would not be parallel, sad face. So it has to have the same slope. It all is about having the same slope. So let's look at one problem that would use this concept. Example 20.4. Find the equation of the line that is parallel to the line 2y minus x equals 2 and passes through point 3, negative 1. How you would solve these, let's take 2y minus x equals 2. We need to find a line parallel to this one. Well, how does that help us? Well, it just gave us an equation, and what we need to do, in all these equations, you always want to solve for y first, isolate y. So let's go ahead and do that. Add the x. 2y equals x plus 2. Divide by 2. Y equals, if it looks like this, you can imagine a 1 there. So it'd be 1/2 x plus, well, what? 2 over 2 is 1. So this is our equation of this line. All right. So we just turned this line into this format. These are the same thing, but you want to graph from this equation here. Then it says find the line, equation line that is parallel to this. So how does this help us? This line is not going through the point 3, negative 1. I'll show you. 1, 2, 3, negative 1. This is our point. This line, if I graphed it, would be at 1 and then up 1 over 2. Notice it does not go through this point. However, we're trying to make this line parallel to here. So how do we do that? Just like we said before, it goes back to the slope. What is the slope? It's our m, and our slope here is 1/2. So we're going to use this 1/2 in our equation because we want to keep the same slope if we want to keep them parallel. Okay? So now we know m. Move it up here. We know m. We know x is 3 and y equals negative 1. Well, those are 3 of the variables out of y equals mx plus b. So therefore we can plug in and solve. Y is negative 1. M is 1/2. X is 3. We are solving for b so we can know the equation of the line. 3 times 1/2 is 3/2. Positive, negative, or subtract 3/2. So negative 1 minus 3 over 2. Multiply this by 2, turn it into 2 over 2. Negative 2 minus 3 is negative 5. So our b, or y-intercept, is negative 5 over 2. Negative 5 over 2. So now we have our y-intercept. We have our slope, so we can insert in our line. Our line would be y equals 1/2 x, 1/2, minus 5 over 2. That's our equation of a line. Just to show you that it's parallel, I'm going to find negative 5/2. That'd be negative 2.5. Be right there. Go up 1 over 2. Kind of. Yeah, my line's up 1 over 2. Up 1 over 2. So there's my line. Notice it's parallel here, same slope, and it does pass through the point that is 3, negative 1. So that is how you do, that is how you solve for the equations when it's talking about parallel lines.